Hello everyone, welcome to the data structures live class. In today's class, we are going to discuss about linked list data structures. Basically, we will study these three operations on linked list, which is the insertion operation, the deletion operation, and the last one is the traversal operation, right? So we will write a program that will be able to create a linked list data structure where we will insert some data in it and we will also do the traversal, right? We will do it in Python, C++, and Java consecutively, and you will be able to understand a lot of important concepts from this particular tutorial. And these include memory referencing and pointers. There are several other very small and very important concepts that are there in this linked list. So if you will miss this whole live lecture, it will the further coming classes which will be on binary trees, queues, they will become pretty useless because they also use this memory referencing and memory allocation to basically run to create those data structures, right? So indeed, this is a very important data structure. So first I will introduce you with this data structure. Before that, we will have to gain a little bit of knowledge about arrays, right? Because linked lists solve a major problem that is there inside of the array data structure. So let's study about the arrays. So if you have used C++ or any other programming language, you might have studied about arrays. Now let's suppose I try to create an array which is an integer array, right? And let's say it is an array of 50 integers. So whenever we create an array, let's see how this array is initialized or this array is allocated inside the memory, right? So let's suppose we have memory like this, and let's suppose it has 50 allocations, right? So something like this is the memory. And similarly, there are so many positions inside of this memory. Let's say that this memory, which is RAM or the main memory, right? It has every block in this RAM has a specific size of, let's say, 1 byte or something like that. And every block has a memory address, right? So let's assume that the memory address starts from 2046. The next memory address will be 2047. I'm just assuming that these are the memory addresses because every block inside of the main RAM is accessed by the CPU using these addresses, right? And they have a very significant role in linked list data structure also. Similarly, we will have 2048 and so on, right? Now, when we create an array, what the program does, what the compiler does is it allocates these 50 blocks continuously inside of the main memory, right? So when let's take a small example, a of 3, right? Let's suppose we create an array with 3 blocks. So it will allocate these 3 continuous blocks, right? These 3, let's say, and these will have to be continuous blocks, right? It will have to be continuous. So whenever we allocate an array, whenever we assign some data, it will get assigned here and it occupies the continuous blocks in the RAM. This exactly is the major problem with arrays, because let's say if I want to create an array of 50 integers and inside of the RAM 50 continuous blocks are not available, right? Let's assume that there will be some cases when the RAM is occupied by some different processes. So there can be a reason when the continuous 50 blocks are not there, right? But there are 50 blocks where you can store this array, but they are not in the continuous manner. So in order to resolve this, we use the linked list data structure. where we store the elements or the data inside of the RAM in not a continuous manner, right? So in linked list, we do not store the elements in the continuous manner. It is allocated in different memory references, which we will study now. So let's assume that I have some data with me, right? Let's suppose these are the 4 integers that I have, 5, 4, 3, 1. This is the data, right? Now if I will create an array of 4 integers, these data will be stored inside the memory in a continuous manner. So 5 will be stored here, 4 will be stored here, similarly 3 will be stored here, and 1 will be stored here. But we do not want to insert these elements at continuous places. What we want to do is we want to find out where the empty spaces are, and the program will insert them accordingly, right? So let's see a basic structure, a basic idea of 5, 4, 3, 1, which is the linked list. We are going to insert these elements inside of the linked list. So the basic building block of a linked list is known as node, right? The basic building block is known as node. A node consists of two things. One is the data, and second thing is a next pointer or a reference, right? So this is actually a reference. So a node contains two things. Inside of a linked list is made up of all the nodes, and a node can contain a data and a next pointer, which refers to the next variable or the next data inside the linked list, right? Because we're not storing them in a continuous manner, that's why we need some memory reference so that we can store it in that way. So let's say we have a first element which is 5, right? So let's see how we can create a node. Let's suppose this is the node, right? And I'm dividing it into two parts. The first part consists of the data. The second part consists of a pointer which points to the next element of the linked list, right? So next element is 4. So it will point here. And similarly, we will also create the nodes 3 and 1 also. So I will create them very quickly, right? The last one is 1. So in the last one, what we will do is, since there are no further elements, we are going to assign this pointer as null, right? So this is just a representation of null. So what we are trying to do is we are trying to allocate the elements inside of the memory, but not in a continuous manner. So in order to access these elements in the sequential order, we will have to use the memory references. Now let's see how this will get allocated in the memory and how this works inside of the memory, right? So I'm just going to draw a very simple diagram here, right? So let's say I have this memory space and let's divide it into some blocks. Right, so let's say these are the blocks, and I'm going to quickly assign them some address. Let's say this is 1025, right? I'm just assuming it. 1026, the next block will be 1027, 1028, 29, and 1030. So in case of linked list, let's see how this linked list is stored inside the memory block. So if you want to store 5, we will store 5 here like this, right? The next element is 4, right? Now we are not going to continuously store it. What we are going to do is we are going to create a memory reference. So let's say 4 is stored here. So what we are going to do is we are going to store the memory reference, which is this one, right? 1024. So this node is actually having a pointer or a memory reference to this node. and we are going to assign them. In C++, we can use pointers to do this assignment, right? Now the next one is 3, so let's say 3 is stored here. So this 4 also has a next pointer. Now this one is going to point to this memory location, which is 1030. So it's like we are storing a data, and we are also saying that the next data is at this place, right? So if we are trying to allocate 5, we are going to allocate 5, and also we are going to tell that 1027 is the memory address where the next element lies. Similarly for 3 also, and similarly for 1, right? So let's say 1 is here. So 3 will have a memory reference which will point to 1028. In this manner, we are going to store all these inside it, and for the last one, which is 1, we are going to assign it to a null reference or a null pointer, right? Now inside of this linked list, there is one more important thing which we have left. So we will the programmer needs to find out where is the starting of this linked list, right? Because if you will not know where is the starting of the linked list, how will you do the traversal? To resolve this issue, what we do is we create a head pointer which points to the first element or the first data inside of the linked list. So we call this as a head pointer, and again this head pointer or a reference contains the address to the first element. So first element is at 1025, so it contains the memory address 1025. Now we can start from this head position, and we can traverse to display or insert any items or even delete any items, right? So in this way we can create we will see how we can create a linked list inside C++, programming, Python and Java also. So this is the basic architecture of this linked list, and the main problem is that it may happen that sometimes we do not have continuous blocks. So we are going to use these memory references. We will have to be very careful when we are trying to assign these memory references, because if you will keep them unassigned, they will lead to a problem known as memory leaks, right? They can lead to memory leaks which can crash your systems or wherever the program is running, right? So if you have any doubts related to this topic, now you can ask me in the comments. I am taking the doubts, and then we will start programming in Python. First I will write the program in Python, and we are going to do it step by step, and at each and every step I will show you what will be the equivalent of that particular lines of code in C++ and Java also, right? So please ask your doubts in the chats. So I will wait for a few seconds. If you have any doubts, just ask me in the comments here. Looks like some people are coming late, so alright, so if you have any doubts, you can also ask it in the comments below of this video. I will also answer that there also, because not much people are live now. So I'm just going to start with the implementation part of the linked list, right? So first of all, let's take a look. We will have to find out how to implement it, right? The implementation will be same in irrespective of what programming language you're using. So I'm going to start with Python here. So right, and we will also see the equivalent in Java and C++ also. So here in the implementation part, we are going to perform some steps also. So let's move on to the first step. First step is to create a node class, right? You will have to create a node class. Now what we are going to do is, the idea behind the implementation is that if we want to create a linked list, what we will do initially is we will first create an empty linked list, right? So we have the head pointer which is going to point to the null reference, right? It is an empty linked list, empty linked list. So first we will create an empty linked list which will be a linked list class, and then what we will do is we will create a node class, which is our first step, right? We will create a node class, and this node class will have data and the next pointer. So whenever we want to insert any element inside the linked list, we will call an object of this node class, and then we are going to when we will create the object of this class, we will assign the data and we will assign the reference, and we will add it inside of this linked list, right? So we keep going on creating objects of the node class. For example, if we want to insert 5, we will create a class. We will create an object of the node class with data as 5, and we will create a next pointer, and we will keep adding it to our empty linked list, right? So let's move on to the first step in Python, how you can do it. So the first thing is we will create a class node, right? So let me enable the zoom so that you can see it clearly. So we will create a node class, and in this class we will define a constructor, and the way to do is to use a init function, which is actually a constructor, right? Now this constructor, we are passing a self. Self means we are passing a reference to the object of the node class. So whenever we will create an object of the node class, this constructor will be called, right? So I'm just going to write here a comment that this is a constructor. Now what I'm going to do is, here inside of the constructor we are going to create the data. So self dot data equals to data, right? So to the constructor we are going to pass data also, because whenever we are trying to initialize our node class, whenever we are going to create a node, we will pass the data, right? For example, if we want to initialize the node 5, we will pass 5 to the constructor, which will construct the values of the data, and the second one is the next pointer or the next reference, right? So whenever we will create a node class, we will create an object of this node class. Whenever we are trying, we know that whenever we create an object of this class, right, we are actually trying to allocate it inside the memory. So whenever we create an object of a class, we allocate it inside the memory, and it will allocate the data and the reference, right? So now initially, since we do not have the linked list, right, so initially the node class will have data and the pointer is going to point to a null reference, right? We can use none, which is a reserved keyword, to just create a null reference, right? So whenever we will create a node class, the constructor will be called and it will initialize the object with data, and the reference will be null, right? Initially it will be null. Then when we are trying to insert the elements, we are going to make sure that we assign this next pointer to the next elements also, right? Let's see the equivalent. This is the step 1. right? So let me remove this first. I'm just going to write here that this is our step 1, like this. The same step can be done in Java and C++ also. In Java, you will have to create a class node, create two items, which will be an integer item data and node next, right? So node next means it is a reference, and this is the constructor, has the same name as of the class we are passing the data, right? So let's say this is int data, and here we will do the same as we have done in in Python, right? We have assigned self dot. Here in Python, to refer to the object of this class, we use self. In Java, we use this, right? This dot data equals to data, and this dot next equals to null. Inside Java, we can access the null pointer using null keyword. And similarly in C++ also, create a node class, make it public, right? By default they are private, so make use of public, create the data, and in order to create a reference inside of the linked list CPP class, right, which is the C++, in order to create this, we will first have to use a pointer here, right? So this small asterisk actually says that this is a reference or a memory reference, right? So it is actually a reference to the node class. So in Java we do not use the asterisk, but in Python you can see we do not even need to assign the to create a memory reference, because it will automatically create a memory reference when we are trying to mark it as null, right? So this is the first step. If anyone has any doubt in the first step, I will take the comments here. Okay, so please repeat the first step. Okay, I will repeat the first step now, right? In the first step, we will have to create a node with data and a next pointer. And the reason why we are doing it is because whenever we want to insert any item inside of the linked list, we will first have to allocate it, right? In order to allocate it, we will create a node class and we will create an object of that node class. In step 1, we are just defining the node class. We are not creating an object. We will create it when we will call the insert function, right? We will create the object when we will insert it. So inside of node, we have the data and a memory reference, which initially is pointing to null, right? So after step 1, let's say we want to insert 5. The node class will look something like this, right? It is going to point to null. So this is what we are trying to achieve. We are trying to get this node, right? This is actually a node. We will get this node, and when we will create the linked list class, we are going to insert these nodes inside of this empty linked list. This is empty initially. You can see there is a head pointer which is pointing to null, and that is the second step, where we will create this empty linked list. And then what we will do is we will keep on adding these nodes inside of the linked list, and in this manner we will be able to get this whole linked list, right? So let's move on to step 2, important step, and it is to create a linked list class, right? We will have to create a linked list class. So initially what we will do is we are just going to create a head pointer or a head reference. We have already seen how we can create a reference in Python and Java and C++. We will create a head pointer which initially will point to null, right? This is a symbol of null. Now let's see how to implement this step in Python. I'm just going to write here that this is now our step 2, right? Stepwise it will become very clear to you. I will create a class linked list like this, right? And inside this linked list class, obviously we will create a constructor which will simply take self, which is basically a reference to this linked list object. Whenever we will create the object of linked list class, we will have to get the reference to that object, right? For that we will use self. Now we will create a head pointer. So whenever we want to create a linked list class, we will create the constructor will be called, and inside this constructor we will create a head node. So self dot head, and we will assign it as null, right, by using none. So in this manner we can create a simple linked list class with a constructor. And here I'm just going to write a comment here that linked list is initially empty, right? So this is the second step, and you can do it similarly in Java also. You can see I've created a class linked list, right? This is the linked list class, and make sure that you are just creating these classes before the class which is our main class, right? So class linked list Java is the name of the file, Java file. So make sure you are assigning it above that. So here we have the node class here, and here we are on the step 2, which is to create a class linked list. We will create a reference which is the head of the list, which is the node reference, and here you can see the constructor. Steps are still the same. This dot head, instead of self we are using this, and we are going to assign it to null, right? Same step. And similarly in C++, we will create a linked list class. In the public section, we will create a head reference. To create a head reference, we use this pointer, this asterisk, and then you can see the constructor here. Now here we do not need to use this or self because this is already a pointer here. And now what we can do is we can assign it as null, right? So linked list is empty initially. So if you are programming in any one of these languages, this is the step 2. Right? So now we have a basic structure of our linked list, right? We have the node class, and what we will do is whenever we want to insert any element, right, we will call the insert function. What it will do is it will create an object of the node class, right, with data and a reference, which is the next pointer, which points to the next data, right? So it will create the object. Whenever we create object, it is allocated inside the main memory, or I'm just going to write it allocate memory, right, with this data and reference. Then what we are going to do is we are going to make sure that this pointer, next pointer, is going to point to the next element, and then finally we will insert inside linked list, right, which is empty initially. So now we have a basic structure of our linked list class which is initially empty, and we have raw data, or we can say a raw node which does not have any reference but a null reference. So the first operation that we are going to perform in this linked list is going to be the insertion operation, which is a very important operation. And basically we are going to insert the elements at the starting of the linked list, right? We can perform insertion at different index also, but we will study them later. Now in order to insert the element at the start, we have some step. We will create the function, but before that, if you have any doubt, if you have not understood any of these steps, please tell me in the chat so that I can answer that. Alright, so we have some doubts here. Bro, what if in Java node class, if we do not use this keyword to allocate as data equals to data? Alright, that's the first question. What's the difference in creating node class and linked list class? Right, two very important questions are there. First question is why we are creating this linked list class separately. Well, the answer is that first we want to allocate the node inside the main memory, right, by creating an object, and then what we will do is we will simply keep on adding these elements, these nodes inside of this linked list class, right? So that's why I've divided it into two steps. I could have done it in the single step. What I could have done is inside of the linked list class we will create the node every time, right? But that will be the code will repeat itself. So what we want to do is we will separately create a node class, which will help us understand that we will have to create an object, and then we will assign these references to get this type of a linked list structure, right? So that's the answer of your question, why we need separate classes. The node class represents this type of a node which is null, and linked list class is the actual linked list, right, where we are going to insert these nodes. So there are two steps, right? The second question was what will happen if we do not use this one, self dot data equals to data? What if we use only data equals to data, right? So whenever we you can see in Java also we are using this pointer. In C++ we do not need this because we are already using a pointer here, right? Now let's see why we are using this. Let me explain this concept of memory reference using this, and in Python we have self. Both have the same use, right? So let's say you create a class A, right? Let's say you have created a class A which has some data, right? Let's say we have some integer data in it. Now what I want to do is I am going to create an object of this class A, right? In order to do so, what I can do is I can just do something like this: A object obj equals to new A, right? And let's say I will just pass the data as 12, and we have a constructor here also. Let's say in this class we have a constructor that takes the data, right? Now I've created an object of this class which is the obj object, and we are passing 12 to this one, right? So it initializes, it creates an instance of this object, it will allocate it inside the memory as 12, right? And we know that memory will have some memory address. Let's say the memory address is 1027. Now I will create another object, obj1. This is an important concept because if you will not know the use of this, it will become difficult for you to understand how the memory references are working. Let's say we are creating another object which is object 1, and instead of passing 12 I am passing the data 10, right? So now this object 1 will be there inside the memory, and it will have some data which will be object 1, and the address will be something different. Let's say the address is 21, right? So whenever we create an object of the class, the compiler will automatically allocate it inside the memory. Now inside of this class A, right, now inside of this class A, if I particularly want to change some data inside the object 1, right? Let's say I want to change the data of object 1, which is 10. I want to change it to 11. In that case, if I will try to write the assignment data equals to 11, right? So this will not work because there can be some other objects which are already calling this. So data will not be assigned by 11, right? So in order to tell the compiler that you will have to change the data of a particular object, right? You can see this object will call the constructor. So what we are going to do is we are going to write this dot data. So if this, you can see this line, whenever we will write this line, the compiler will create an object and it will also call the constructor of the class. Now we will have to tell the constructor that the data which we are trying to change belongs to this object 1. So how we will do that? We will have to use this dot data. This means that the object that is calling this constructor. So if various objects, you are creating various objects, you can change their data using the constructor, but you will have to specify this dot data. So this dot means it is a reference to this memory, right? Since this line will call the object 1, which is 10, which is stored at 1021. We are taking this as an example only. That's the main reason why we are using this dot data, to change the data of specific objects, right, to the object which is calling this particular constructor, not all the objects, right? That's why we use this, and in Python we use self. Both have the same concept, right? So here you can see I have used self dot data, and here I've used self dot next. Self means that whenever we will create an object of this node class, it means change the data and the reference of that particular object, right? So these are the two steps. Now let's move on to the next step, which is to insert the data. Right now we want to insert these nodes inside of the linked list class. Right, so we want to insert at the start. So initially the head is pointing to null, right? We know that head is pointing to null. So in the insert function, we will first create an object of the node class, and then what we are going to do is, let's first create the functions inside of this linked list class, right? Here I will define a function which is the insert at start function, and this function will take two arguments. One is the self and second one is the data itself, right? Now what I'm going to do is, this insert function, since it is going to insert something inside of the linked list at the starting position, concentrate here. There are two steps. First one is we will create a new node, which is actually the object of the node class, right? So let's first create the new node. I'm going to create a new node, and which is an object of the node class, right? Now you can see that node class has a constructor. We will have to pass the data. So here I will pass the data, right, which we have got from the function parameters. Now we have allocate, whenever we are going to call the insert at start function, first of all we will call the object. We will create an object of this node class which will allocate the data, and the next reference is null, right? So since this next reference is null, we will have to change this reference, right? So let's see how we can change this reference. The way to do is to use the object of the node class and a dot operator. When you will write dot, it will show you data and next. So click on next or just type next, right? We are going to reassign it. Instead of null, we are going to reassign it to the self dot head, right? Self dot head means the head pointer of this linked list class, right? So we will create a linked list class which will, so let's first create the linked list class and then we will come to this line. Let's create the object of this linked list class, right? Let's call this object as new linked list, and it will be an object of the linked list class. and the constructor, you can see it is not taking any parameters, so it will be like this. So calling this line, it will create an object of this linked list class, and it has a head pointer which is pointing to null position. And now let's say we want to insert some elements, so we will call the insert at start function, and let's say we want to insert 5 at the starting position, right? Similarly in Java, you can see inside of the main function, this is the main function. I have created an object new LL, which is the new linked list object, and I'm calling the insert at start. I'm passing two arguments. First, I'm passing the object here, and then I'm passing the data. I'm passing the object because I want these data to get assigned to this new linked list, right? Which we are not going to create different linked list objects. We are going to create only one object because we have only one linked list, and we are going to insert these elements inside of the linked list, right? So now let's take a look at insert function, which will insert this, right? Now insert at start function will take this self parameter, which actually refers to the object which has called this function, which is the new linked list, right? New linked list is the object which is calling this insert at start function. That's why we're using self, and data is passed, which is 5. We will create a new node using the node class. That's why we have created the node class at the first step. And the next step is because the node initially is pointing to null, we will have to change this reference. We are going to assign it as self.head. Now the reason why we are assigning it as self.head is because we are performing insertion at start, right? So here let's say we have some numbers inside of this linked list already. Let's say we have inserted 4 and 3, right? Let's say this is the status of the linked list before inserting 5. Now let's say I call the function insert 5, right? When I will call this function, it will first create the object of this node class, which will be 5, and the next pointer is pointing to null. Now what we are going to do is, let me just draw 5 here, right? So 5 is here, and we have the next pointer which initially is pointing to null. Now instead of pointing it to null, we are going to make sure that this pointer will point to 4. Then only it will be inserted inside of the linked list, right? And how can we know that this is the first node of the linked list? Because we want to make sure that the node we want to insert inside of the linked list is going to point to the first node of the linked list. And how can we do that? We can use the head pointer, right? So wherever this head pointer is pointing to, we are going to point the node at that position. And then we are going to reassign the head pointer, right? Now head will not point to here. Now head will point to the node that we are trying to insert, right? So let's write the third step. Here in this step, I have assigned the next pointer of the node to point to the head node, right? Self.head means that it is a head node or the first node, right? Simple. So self.head, these are the two lines, and the next one is that we will have to reassign the head pointer. And where will the head pointer point, right? So head pointer is there, self.head. Head is going to point to our new node, right? So this one is our new node. So in the next line, we are going to change this head pointer, because now we have inserted some element inside the linked list. We will have to change the head pointer so that whenever we are trying to traverse, this head pointer will say that this is the first element. So the resultant linked list will be 5, 4 and 3. right? So let's perform this last step. It will point to new node, right? So in this way we can insert elements inside of a linked list. There are 3 steps. First step is to allocate the node by using the object of the node class, which is here. The second step is assign the pointer of the new node, the reference of the new node, to self.head, right? So self.head is the first node. So first node, and here we are going to assign it to the first node. And since now the linked list has changed, we will have to reassign the head pointer and it will point to the new node. So that's the basic idea. In Java, it is also simple. We have created a start function. We have 3 same steps here. We will create an object of the node class providing the data and using the new operator. And then we will assign the next pointer to point to the head pointer, right? This dot head means the first node. So new node next is going to point to the first node. In the next step, we are going to assign the head position to the new node. So these are the 3 sub steps inside the insert at start. In case of linked list, the syntax will change. You can see how we are creating an object of this class. We are using a pointer here, right? And new node, we are not going to use dot operator. Dot operator does not work in C++. We will use this dash and this greater than symbol instead of using dot operator, right? Here we have the new node dot next. Here we have new node and next, right? So it basically represents that it is the next pointer of this new node. We are going to assign it to the head node, and then we are going to reassign the head node to point to the new node, right? So that's how we can do insertion inside of the linked list. If you have any doubt in this step, please ask in the chat section. Let me take a look at the chat section. Okay, so I think I started earlier, so that's why people have missed the theory part of this explanation, right? So there is no problem. If you have any doubts related to this, you can ask it in the comments below. I will try to answer them. And after this live stream will end, you will be able to just it will be available inside the data structures live playlist, right? We have a playlist, data structures live, and in that playlist it will appear in 1 or 2 days. You can just comment there also, and I will reply sooner, right? So this is how we perform insertion in a linked list. And now the next step is to do the traversal, right? First we will do the traversal to check whether these nodes are inserted inside the linked list or not, right? So let's insert some more elements, like I'm going to insert 4, and I'm also going to insert some more elements like 3 and 1, right? So we are going to insert all of these 4 elements inside of the linked list. These are the steps. These are very clear steps. Just if you will read it 1-2 times and you will listen to what I said before, you will be able to understand. These are very simple steps, and you can see how these are performed here. One more thing, this live tutorial will also be available inside the Android application. So I will drop all the codes in Python, Java and C++ there, so that you can access them, right? You can just copy them and you can run them yourself, right? So next move is the traverse, right? Now traversal is very easy. Traversal basically means we want to display the contents of the linked list, right? So we just want to display the contents. Now in order to do so, what we are going to do is we will start from the head node, right? We will start from the head node and we will keep going on displaying the data of these nodes, right? So let's say this is the node. Let's say after inserting all the elements, let's say this is the resultant linked list, right? So these are the resultant, this is the resultant linked list that we have. Now if we want to do the traversal, we will run a while loop, right? Now since we want to make sure that this head pointer will point to the next node so that we can display the results, we should not change the value of head node because it is basically a part of the linked list. So what we are going to do is we are going to create a temporary variable which is going to point to the head node, right? So it will be equal to head, so it is also going to point here. And then what we will do is we will check whether temp is not equal to null, right? So we will keep updating the value of this temporary pointer, and whenever it becomes null, it means that we have reached to the end of the linked list, right? Now here what we are going to do is we will have to increment the temperature, this temporary value to point from first to the next node, right? So before doing this, let me just open the Python IDE and uh, let's create a traverse function first, right? Here I will create the traverse function which has self, right? And here I will create a temporary node which is going to be equal to self.head, because we do not want to mess with the head pointer. We will not update the head pointer because it is a part of the linked list. We are going to update the temporary pointer. We are going to use the temporary pointer to display the contents of the linked list. Now what I'm going to do is I'm going to create a while loop, and I will say that while temp is not null or none, right? If it is not equal to null, it means we have not reached the end of the linked list. So what we are going to do is we are going to print the data, right? We are going to use temp dot data to print the data, right, like this, and we will add a space here, right? So this is actually displaying the contents of the linked list. So first you can see that after inserting, this is our linked list. So temp is pointing to 5, so temp dot data, right? So since temp is equal to head, temp also has its data and the next field, right? It also has these two things. So when temp is pointing to 5, the data is equals to 5 and next is pointing to 4, right? So I'm going to say that next is pointing to 4, right? If I will use next dot next, right? So next dot next means the next of this 4, right? So this node 4 has a next, so now this is going to point to 3. So this is a very important concept, that if we are using next dot next, it will point to the 3, right? Initially it was pointing to 4. If I use next, which is single times, it will point to 4. And then again, if I will use next dot next, it means the next of this 4th node, right? So what I'm going to do is I've printed the data. Now it's time that we update the data, right? We will have to, sorry, not update the data, we will have to update the temporary pointer, right? So how can we do this? We are going to assign the temp pointer to point to. All right. Okay, so I don't know why this has inverted. Let me just cross it, or let's just do it here, right? I'm just going to update the temp pointer to point to the next one, right? To the next node. So this while loop will keep running. It will display the data and it will update the temp to point to the next node. In this manner, we will be able to do the traversal, right? So this is the program here. And the last thing that we have to do is the deletion. So before this, we can see the code in Java also. In traverse, we will see whether the head is pointing to null, because in that case it will be empty, or else we are going to create a temporary pointer which is a reference of the node class, and it is equal to this dot head, right? Similar to this one. Similar to temp equals to self dot head, in Java we are going to write this dot head. Now we will create a while loop which will run like this. It will display the data and it is going to make the pointer point to the next node by doing temp dot next. Now in case of arrays, if we want to display the data, we keep on incrementing the index value, right? In the case of linked list, we do not have the index values because it is not stored continuously. So we will have to use the temp equals temp dot next to update the temporary pointer to point to the next node. So I'm just going to write here point to the next node. All right. And similarly in Java, here we have the code in C++, right? Traverse function. We will create a temporary reference, right? By using a pointer here. In C++, we use the pointer. We have created a while loop, temp not equal to null. We are checking that. We are displaying the value of temp data. We cannot use the dot operator. That's why we are using this to access the data of this temporary node. And then we are going to update the temporary pointer to point to the next node by using temp equals to temp and arrow next, right? Because we cannot use temp equals to temp dot. So in this manner, we can display the contents of the linked list. And now the next operation that we will have to do is the last one, which is the deletion operation. So let me create a new file here. I will create a new file quickly here. Just let me align it, and here just wait for a second. I'm just trying to create this for the last step, which is the deletion, right? So the last step is to delete. Is to perform the deletion, right? And we are going to delete the node from the starting, right? So now we have the linked list as, let me just display the linked list. We have 5, then we have 4, and then we have 3, and then 1, and then null. We also have a head pointer which is pointing to the first node. Now if we want to perform the deletion of any part of this node at the starting position, right? So this is the node at the starting position. If we want to delete it, let's see what are the operations, what are the lines of code that we will have to write. We will use the same strategy to delete the node at any particular position, right? We will just we will create a temporary pointer and we will keep checking the value of data that we want to delete and the data of the node using the if case, right? We will use the if the data that we are going to pass is going to be equal to the data that we have found from the temp, right? So temp dot data. If this will be equal, we will perform the same step, which is the deletion of this at the start, right? Now if we want to perform a deletion on this node, we will have to remove this. Now let's see how we can do this. First of all, we will do it in Python, right? We will first create a delete node function, and after deleting the node, we are going to display the whole content of the linked list to check whether the node has been deleted or not, right? So here I'm going to write traverse again to display whether the node is deleted or not, right? Here I'm going to define a delete member function, which is delete node, and here we will pass self, right? And the node that we want to delete, which is the D node, right? So here let's pass to the delete node. We are going to pass, let's say we want to delete 1 from the linked list, so we are going to pass 1. Now here let's define the function delete node, which will delete the node. Here you will have to be a little bit careful because we are going to use a lot of memory references. So first of all, we are going to create a temporary reference which is equal to the head pointer, right? So that we do not reassign the head pointer to some other value. We want the linked list to be intact. The next step is to check, right? We're going to check self dot head dot item, right? Sorry, dot data, right? So what we're trying to check is whether the data is at the starting position, right? So self dot head dot data will give me 5, because in the linked list you can see at the head pointer we have 5 here, right? So if self dot head dot data is equals to the node that we want to delete, which is the D node, if this is the case, what we are going to do is we are going to assign the first node, which is the self dot head. We are going to assign this pointer to point to the self dot head dot next, right? So let's take a look at this line. It is a very important line, right? So what we are just trying to do is we want to delete this, right? So what we will do is we will make sure that this head pointer is, instead of pointing to this node, it will point to the next node, right? Then only we will be able to delete this node from the linked list. So we are going to reassign this head pointer from pointing to this place to this place. So now head will point here. Since head will point here, if we will call the traverse function, it is going to display 4, 3 and 1, right? So that's the first line, that's the first case. We are going to check the value, right? So let's say we are deleting the node 1, right? 1 is passed to as the D node, right? So the value of D node is equals to 1. We are going to check this value in this the data that we are storing. Whenever this becomes equal to this, then only we are going to perform, then only we are going to reassign it, right? So now let's say we want to delete 1. So this temporary pointer will go from here to here, and it will check the value. If it is equal to 1, we are going to reassign the head to point to the next node. So if we want to delete 1, the head will point to null, right? So the linked list will be empty. Now let's say if we want to delete 3, right? If we want to delete 3, we are going to make this head pointer assigned to this place, right? which is actually self dot head dot next. As you can see here, self dot head equals to self dot head dot next. If this is the case, it means that we are going to return out of this, right? Now this first case is basically just checking, right, that the node that you want to delete, which is the D node, is at the start, right, or is the first node. So if the self.head.data is equals to D node, right, which you can see here, if we are passing 5 to the delete function, then we will check whether this D node is equal to the data of the head node, which we are using self.head.data. If that is the case, we are just going to assign head to point to the self.head.next, which is here, right? Self.head is pointing to 5, self.head.next is going to point to this one, which is 4. So that's the first case. Now let's move on to the next case. Now if we want to delete some element which is not at the starting position, we will have to create a while loop, right? We will first have to reach that node. So how can we reach that node? We can use the temp, right? We will write if temp is not none. If temp is not none, it means that we have not reached the ending of the linked list. We are going to check, right, if self dot head dot data, sorry, it should be now temp dot data, right? Temp dot next dot data equals to the node that we want to delete, right? So let's say the node that we want to delete is not at the starting position, then this case will not run. Then we will run a while loop, and this while loop will keep going from the first node to the last node until and unless it becomes null. And then we are going to apply this case. We are going to check whether the temp dot next dot data, right, what this means, right? So let's say we want, let me just rewrite the linked list here, 5 4 3 1, and this is going to point to null. Now let's say I want to delete 3, right? If we want to delete 3, you can see that 3 is not at the head position, right? So the first case that we have written here, which is if self.head.data equals to this, then we are going to do this. So we can't do this, right? So this case is not holding true. Now we will go inside of the while loop. Now inside of the while loop, we have the temp pointer, right? And you can see we have written an if case which says temp dot next dot data, right? So why we are using temp dot next dot data? Well, the reason is that let's say we want to delete 3, right? So here first let me write here this whole if condition. What we are going to do after this, we are going to assign the temp. We will just break out of this loop, and we are going to assign temp equals to temp dot next here, right? I will explain you what I have done here. All right, so what we're trying to do is we are trying to run a while loop which will go from the first node till the last node, and here we have a condition which will check whether the temp dot next dot data is equals to D node, right? So what we're trying to check is, let's say temp is initially pointing to 5, right? In the while loop, temp is initially pointing to 5. So what we are checking is whether the next data is the data that you want to delete, right? So temp.next.data at this position is 4. Why? Because temp is pointing to 5, dot next means 4, and data is actually 4 here. So temp.next.data equals to 4. We are checking this value with the D node, the node that we want to delete. So now you can see in this case, this is not true, right? This is false. So what we are going to do is we are going to break out of this loop, right? We are going to break out of the while loop because this is not true, which you can see here. We are using the break condition. It breaks out from here and it updates the value of temp as temp.next. Now temp is going to point to here because we have reassigned the temp. Now the temporary pointer is pointing to 4. What is the value of temp.next.data now? Now this value will be temp is pointing to 4, temp.next is this one, and the data is 3. Right? So temp.next.data is equals to 3. You will get to know why I'm using temp.next.data is because I am trying to find out the previous node of the node that we want to delete, right? So the temporary pointer will point to the node where we want to perform the reassign the references, right? So if we want to delete 3, we are going to stop the temp pointer at 4. That's why we are using the break, right? So whenever this condition is true, we are going to break out of the while loop. So what is the idea behind this? It is a very important trick and very few people know this trick. I've used this trick myself, that we can actually stop the temp pointer from updating. We are just going to stop it before the node that we want to delete, right? So actually what is the node that we want to delete? We want to delete 3, right? You can see here we want to delete 3. So what we are going to do is we are going to update temp by checking whether the next node, the data of the next node equals to 3. So now if it is true, we are going to just break, right? Which you can see here, which we are doing it. If it is equal to the D node, we are going to break, right? So temp equals to temp.next will not be followed because we have come out of this while loop, right? So after we have done this break, now temp is pointing to 4, and now we can delete this node. So now the resultant linked list will be 5, 4, 3 and 1 here, and this is pointing to null. Now the temp pointer is pointing to 4 and we have come out of the loop, right? So that's the trick we are using. We want to delete the node 3, right? So what are the assignments that we are going to do? We are going to make sure that the next pointer of this temporary node is going to point to the temp.next.next, right? So we will reassign this pointer from pointing here to pointing here, right? So let's see how we can do this. First of all, we will check that whether the temp.next is not null, right? Because if the next data of this temporary variable is null, it means that we have reached the end of the linked list and we have not found the element that we wish to delete, right? Now we will have to do the reassignment so that the node that we want to delete, we can delete that, right? So here in this case, if it is not null, or let's say if it is null, we are going to just display that item not found, right? Hope you have understood this very simple case here. Remember that it is out of this while loop, so you will have to take care of these spaces. Make sure that it is out of this while loop because we have done a break. So the temp is now pointing to the 4, right? Here I will have the else case. So if temp.next is not null, right, you can see this is null. So if it is not null, in the else case, we are just going to assign the next pointer of the temporary node to point to the next of next node, right? So next of next is next dot next, right? So a very important trick here, right? Let me repeat this step. Whatever you want to delete, we will first check whether it is the head node. If it is the head node, we can simply do self dot head equals to self dot head dot next. If you want to delete some element which is there, which is lying in between of the linked list, we are going to create a while loop, and we will update the value of temporary pointer only when we are going to update it again and again until and unless the next node of the temporary pointer is the node that we want to delete, right? For that, we are using this condition, if temp.next.data or the next node is the deletion is the node to be deleted, we are going to break out of this loop. Now when we will break out of this loop, the temporary pointer will not update, it will stay here. Now it's here, temp is pointing to 4. What we will have to do is we will have to assign this pointer, we will have to reassign it because we want to delete 3 from here. So temp.next will have to point to this node. So how can I access this node? This node is actually temp.next, right? This is next and dot next. So we are using dot next 2 times. You can see here temp.next equals to temp.next.next. So in this manner, we will be able to delete the element. Same steps are there in Java. In Java, you can create a delete function. We will pass the reference of the new linked list and the node that we want to delete. We will create a temporary pointer. Again, there is a condition that checks whether the head pointer, whether the node that you want to delete is the head, right? If it is head, then we are going to return it after assigning head pointer to the next one. Else we are going to run the while loop. Again, we will check and we will stop this while loop from updating the value of temp if the next node is the node that we want to delete. After doing all these things, we will have to update the references. We will first check whether the next node, whether the temp.next is not equal to null, because if temp.next is null, it means we have reached the end of the linked list. If it is not true, we are going to assign temp.next equals to temp.next.next. C++, same thing. Instead of we will have to just use pointer here, right? We will use a pointer, and if head dot data, instead of dot, we are just going to replace it with these dash and arrow. Else everything you can see is same. This is the loop. We will break out of the loop, and then these are the conditions to update the references, right? So let's run this final program that we have actually come up with. Again, I'm telling you that all these 3 programs is available inside of the Android applications. You can access them and copy them, and you can take a look at that, right? So I'm just going to run this. So now you can see here it inserts 1, 3, 4, 5, and then it is deleting 1, so the list will be 3, 4, 5, right? You can format it according to you, right? So here I can say I'm just going to print here after deletion, right? I'm just going to save this and let's run this final program. So now you can see initially the linked list has these members 1, 3, 4, 5. After deletion, you can see 1 has been deleted, so the resultant is 3, 4, 5. In Java also, if we will run this, right, you can see this is the program 1, 3, 4, 5, and after deletion it's 3, 4, 5, and similarly it will happen in C++ also. So hope that you have liked this tutorial. uh, I'm just going to take a look at the chats, and after this I will just end this uh, tutorial, this live stream. We will come tomorrow, and or after some days I will drop the timings in the community post, and you will be able to come there, right? So I'm a final year student. Which languages will be best for data structure and algorithm, right? So first thing is, a lot of people ask this question: what is a good programming language to study data structures, right? You can see that I have implemented data structures in Python, in Java, and in C++, and the code in all these languages are almost the same, right? There are minor syntax changes. It is recommended that you implement data structures in C++ or Java. The reason is, in most of the company interviews, from my experience in my region, I've seen that in interviews they make it mandatory that you will use data structure for uh, in Java and C++. But if you want to learn the basic concepts and you feel comfortable in Python, with Python, there is no such issue, right? But I started with C++. I studied data structures in C++, and then I was studying Java for Android development. I've created an Android app, so I know Java, and I've implemented data structures in Java. And Python, I've used it in machine learning a lot, so that's why I have a good idea about all these languages. You can just choose one, whatever you want to, right? So if you have any questions, you can ask again. uh, Bro, you didn't clear my doubt. What was your doubt? I will take a look at this. Bro, please give some pause on doubt asking time. Okay, I will give some pause on doubt asking time, but you have said that you have missed the theory part, so I thought that uh, you were gone, right? Are coming too slow to you to reach as it's live. Yeah, there is some delay in this, and that's the main reason these are coming late. So I've already cleared your doubts here. I think I've missed the theory explanation. Yes. All right. So I'm ending this live stream now. Thanks for coming.